Every Challenge question, part 27 is book 2, review chapter 2. First question about segments here. If this this arc length is x and this arc length is 3x, this angle in here is clearly pi over 2 because the angle is proportional to the arc length that it creates. And this is, of course, 1 to 3, 4 parts in total. Divide 2 pi by 4 and you get pi over 2. Good. The radius is r. And so I think I can just describe p by doing r squared theta over 2 minus half r squared sine theta. Sine pi over 2 is, of course, just 1, because this is essentially right angled, which means it's just a half times r times r. But of course, when I take those two things away, it looks a bit like this. Q is just the whole area, which is, of course, pi r squared minus p, which gives me this. That simplifies to this. And now the answer is just this to this. Now, they didn't ask me to simplify this, but obviously you can just cancel out all the r squareds because r isn't 0. And then you can times everything by 4, and I decided to leave it like that, so that's fine. Question 2, they asked me to do in, I think, the chapter 6 challenge questions. So I'm not going to do it again, except I am, because basically it doesn't ask me to prove any of what I'm about to do. It just express the lengths as single geometric functions. So okay, this is sine x, this is cos x, this here is tan x, this is cos x, this is sec x, and this is cosec of x. The proof of that is in chapter 6's challenge questions. Last one about parametric equations. So we're going to take away 3 from both sides here and then square it. And that will give us this. We're going to we're going to add in 1 to this side and then square it. And that gives us that. If we add this to this, 16 sine squared plus 16 cos squared is just 16 lots of 1. And so we get this plus this is 1. And this is a circle, sorry, is 16, of course. So this is a circle, center 3 minus 1, radius 4. Except it isn't, because of the restriction on t, the kind of weird and interesting restriction on t that they've given us here. What this actually means is that if I put in t as minus pi over 2, so sine is an increasing function between these 2 points, right? Because it starts down at minus 1 when you put this in, and then goes up to, I think, root 2 over 2 when you put this in, and it just increases between the two. So, okay, the smallest thing we can get into here is making sine t minus 1, which makes this whole thing minus 1. Sorry, whole thing plus 1? No, the whole thing minus 1, of course. Good. The whole thing minus 1. And when you put in pi over 4, you get 4 times 2 over root 2, or 1 over root 2, it doesn't matter. Or root 2 over 2, it doesn't matter how you say it. In either case, you're going to get 2 root 2 plus 3. So that's the domain of x. And the range, of course, also doing the same kind of thing. Now, cos is symmetrical between these two things. So when you put in minus pi over 2, you get 0. So the smallest y can be is minus 1. And then it increases up to when you put in t as 0, and this becomes 3. And then goes down again when you put in the stuff bigger than 0. So I think that means y ranges between minus 1 and 3 is what I'm going to say here. So okay, the domain, I can't draw this graph past minus 1 or past 2 root 2 plus 3, which is like roughly 5.8. And I also can't draw between lower than minus 1, so lower than this horizontal line here, or above the horizontal line 3. Now the radius of this circle that I'm just drawing in to start with is 4 because of this. So notice how this range here up to 3, well that's 4 above the center. So it can just about get to there. And likewise, domain minus 1 is 4 away from the center of this direction, so it can just about get there. It's the other restrictions that are more tricky. We can't be below this red line, so all of this part of the circle goes. And we can't be to the right of this red line, so all of this part of the circle goes. So you're left with this being the point. Notice how it's on x equals minus 1 and y equals minus 1, so this is the point minus 1, minus 1. And this was the point when x was 2 root 2 plus 3, which happened when t was pi over 4. So just put pi over 4 into here, and you'll get 2 root 2 minus 1. So okay, we need to find the length of this here. So essentially I just need to find out how much of the circle is left, and just do 2 pi r times that amount that's left. So okay, how do I do that? Well, the radius is still 4, that's fine. Just notice that if you build a little triangle this way, the height of that triangle is 2 root 2 minus 1 minus minus 1, which is just 2 root 2. And the width across is 2 root 2 plus 3 minus 3, which is just 2 root 2. And so this is a nice isosceles triangle, and so this angle here is pi over 4, which means this angle here is 3 pi over 4. And because the radius is 4, I can just say that the length of this is just r theta, and so it's this times 4, which is just 3 pi, and that will be my answer. Thank you for watching.